Let's look at D. So we've got so we got magnesium, and it's reacting with nitrogen to produce Mg3N2. So if I don't balance the reaction for you, which I probably would not, even though it's balanced there in that question, you want to make sure the reaction is balanced. Sometimes it will be correct if you just make sure that you have equal numbers of magnesium on both sides and equal numbers of nitrogen on both sides. So you could just start this by putting a 3 here, 3 magnesium on both sides, 2 nitrogen on both sides. It looks like it's done. But there will be other examples where that is not fully balanced because the charges won't be balanced. So what we need to do is to think about the half reactions and make sure that the number of electrons donated by one species is the same as the number of electrons accepted by the other species. That's how we make sure usually that the charges are balanced as well as the elements being balanced. So I want to focus, if I'm looking at half reactions, if I ask you to write the half reactions, one half reaction will be the reaction that just shows what's happening with the magnesium. So what's happening with the magnesium? It's going from neutral to Mg with a 2 plus. How do I know that it gains a 2 plus in the end? Because I know when a metal joins with a non-metal, if the metal's in group 1A or 2A for sure, it's going to have the noble gas configuration, and for magnesium it needs to have a +2 to make a noble gas configuration. And I can make sure that that makes sense with the formula here as well, because if I have 3 +2s, that's a total of +6. And what will I expect the charge on the nitrogen to be? Well, nitrogen is joining with the metal. It should also make its noble gas configuration. It needs to do that by picking up 3 electrons. So it's probably going to have a 3 minus. And if it picks up a 3 minus, and there are 2 of those, that's a 6 minus total. Right, so as a neutral compound, the individual ions involved have to be present in numbers that balance the charge. Right, so that makes sense for the magnesium. If the magnesium is going from 0 charge to a +2, that means it's giving away 2 electrons. So we would show those as being produced in that reaction. So the half reaction shows whether electrons are consumed and taken up, or whether they're released and given away. If they're released and given away, they are shown as a product of that process. They're being produced by that process. So that's one half reaction. Looking at the other half reaction, I would focus on what's happening with the nitrogen. So it's going from N2 to N3 minus. And that's got to be balanced. So when I'm balancing my half reaction, I just have to make sure I have the same number of the element on both sides. So if I have an N2 converting into 2 N3 minuses, what's happening with the electrons? Is it picking up electrons? Is it giving electrons away? How many are involved? It's picking up how many? 6. Each nitrogen starts off with no charge and becomes a 3 negative. So each nitrogen has to pick up 3 charges, and I've got 2 of those, so that's 6 electrons that I have to pick up. So now I've got 2 balanced half reactions. To get the overall net reaction, I have to add those together, but I can't add them together unless the number of electrons cancel. So that means I've got to multiply this top one by 3 so that the number of electrons consumed will be equal to the number of electrons produced. One substance is giving electrons to the other substance. The number of electrons given away by the one substance has to equal the number accepted by the other substance. So I need to multiply this by 3 so that the 6 electrons produced by the magnesium will be the same as the 6 electrons consumed by the nitrogen. Now that they're equal, I can cancel them, and I add everything on the left and everything on the right, and I get the overall balanced reaction. And this is the same as this. There's no difference. Showing the magnesium 2 plus, I've got 3 of them. 3 magnesium 2 plus, 2 nitrogen 3 minus, 2 nitrogen 3 minus. This is just showing them together. Maybe their charges attraction holds them together. This is showing them produced separately, maybe before they have a chance to meet up. Either way, they are the same substances, so either way is correct. Right. There's no species that isn't involved in the reaction. Each species, both the magnesium and the nitrogen, are involved in one way or the other, either by losing or gaining electrons. So they're all important to the reaction. None of them are unnecessary. So if you want to show the net ionic equation, you'd be removing anything that appears exactly the same on the left as it does on the right. But there's nothing like that here.